Bismillahirrahmanirrahim. We'll continue. We did this problem. Now we'll continue doing the other problems. Okay. The problem with the solid obtained by rotating the region bounded by the curves x equal 1 minus y square. How to graph this function? First things, we graph the function. This is parabola, opens to the left. So I have 1, and then it's open to the left. This is the parabola. And x equals 0, which is the y-axis. I have the y-axis is x equals 0. When they say x equals 0, he means the y-axis. Okay. About the line, x equal minus 1. And I have it about the line, x equal minus 1. This is 1. By the way, this is 1, and this is minus 1. Y values, about the y values. About the line, x equal minus 1, which is this line. This is x equal minus 1. Okay. So this is and we're talking about this area. X equal 1 minus y squared and x equals 0. X equals 0, which is the y-axis. Okay. So I am talking about this area, this region. Okay. Yeah. Which is bounded between the y-axis and this curve. Okay. Now I take the strip this way, perpendicular to the line of rotation, which is this one, x equal minus. This is x equal minus. Okay. So I have what? This, since I'm doing it in a different color. So this is the one I'm working with. Now, since I'm dealing with this axis revolution, so I have the big one minus the small one, minus this, to get this. So I have capital R of y. I'm doing everything in terms of y. It will be what? It will be the function, which is 1 minus y squared minus 1. Okay. And that is 2 minus y squared. Small r of y, which is this one, will be what? Will be 0 minus 1, and that is 1. So the area will be by r square y, which is 2 minus y square minus 1 square. That will be my area. And the volume and the limits of integration are what? This is y equal minus 1. This is y equals 1. So the limits of integration from minus 1 to 1 of this function. By times 2 minus y squared, which is what? 4 minus 4y squared plus y to the power 4, minus 1 dy, which is by minus 1 to 1. Actually, I can make it 0 to 1 times 2, since the function is even. This one is an even function. So I can make it 2 and make it the integral from 0 to 1. So that will make the calculation easier. So I have 3 minus 4y squared plus y to the power 4 dy. That gives me 2 by times 3y minus 4y cubed over 3 plus y to the power 5 over 5. That from 0 to 1. That gives me 2 by 0. I don't need 3 minus 4 over 3 plus 1 over 5. That give me 2 pi. This is over 15. 45. 15 over 3. 5 minus 20 plus 3. So it will be 48 minus 20. That's 28. So I have 2 pi times 28 over 15. And that give me 56 pi over 50. Okay. Move to the next one. Now I have the base what? I have the cross-sectional perpendicular to the x-axis. So I'll work in terms of x are what? Squares. They are squares. Now let us see the base. Let me grab the function, see which one is above the other one. Y equal x square. This is y equal x square. Y equal 2 minus x squared, which is this one. Okay. I need to find the points of intersection between these two functions. Sorry, the red one. Okay. Let me just do it quickly. This is y equal x squared. This is 2 minus x squared. This is 2. Okay. Now, I want the cross section to be perpendicular to the x-axis. So my line is this. This is the base. So the base will be what? Will be 2 minus x squared minus x squared. And that is 2 minus 2x squared. That will be the base. Okay. Now, I need to find the points of intersection. What are these points? These points are what? So I will equate the two equations. 2 minus x squared equal x squared. That implies 2x squared equal 2. So x squared equal 1. So x equal plus or minus 1. So this is minus 1. This is 1. Great. Now, squares. What is the area for the squares? X squared, or the base square. The base square. We said one side lying along the base. Okay. So this is the base square. Okay, so the volume will be what? Integral from minus 1 to 1, the base square, and this is the base. So 2 minus 2x squared all squared dx. Oops. And that equals to what? Minus 1 to 1, 4 minus 8x squared plus 4x to the power 4 dx. I notice this is an even function. Also, I can take 4 common factors. Let me do it at the same time. From 0 to 1, 1 minus 2x squared plus x to the power 4 dx. So this one will be 4 times x minus 2x cubed over 3 plus x to the power 5 over 5. All of that from 0 to 1. So 4, 1 minus 2 over 3 plus 1 over 5 minus 0. So that's it. So I have 4. This is 15. So I have 15 minus 15 over 3, 5 times 2. That's 10. 15 plus 3. So that'll give me what? 8. Is it? 15 minus 10. Yeah. Where is the mistake? Sorry. Now I took 4 common factor times 2. So this is 4, which is the common factor, 2 because of the even function. So that will be 8. So it's 2. There's 2 missing. 8. This is will be 8. So that will be 64 over 15, which is this one. Okay. The base of the solid in region bounded by the lines, this, if the cross sections perpendicular to the x-axis are equatorial triangles. Okay. First, I need to find the base. Let me grab the function. Grab the lines. I have y equal 4x, y equal 0, which is the x-axis, and x equal 2. This is x equal 2. Okay. So the base, will be my base. That will be the base. The base will be the line minus 0. 4x minus 0. That will be 4x. Okay. And it's going from where to where? From 0 to 2. From 0 to 2. And this equatorial triangle, what is the area of the equatorial triangle? Square root of 3 over 4. The base square. That's it. So now what will be my area? What will be my, yeah. And that is what? The base is square. That gives me square root of 3 over 4. 16x squared. That will be 4 square root of 3x squared. Good. So now what is the volume? The volume will be the integral from 0 to 2 of this 4 square root of 3x squared dx. That gives me 4 square root of 3 x cubed over 3 from 0 to 2. That x cubed, it will be 8 times 4, 32 square root of 3 over 3, which is this. Nice. The volume of the solid obtained by revolving the region bounded by the curve this about the line y equal minus 1. Okay, let us see the graph. I have y equal cosine x, which is here up to there. That is the function. And they have y equal 0, which is the x-axis. And for x between 0 to pi over 2. And they want this about this line, y equal minus 1. Okay. So I have this, which means what? It is what? It is the long one minus this. So I have capital R of x, which is the function, which is cosine x, minus the line, which is minus 1. So that will be 1 plus cosine x. The small r of x will be 0 minus minus 1, and that is 1. What is my area? It will be by r square, which is 1 plus cosine x all square minus 1 square. So what is my volume? The volume is the x values from 0 to pi over 2. From 0 to pi over 2 by of this minus 1 dx, which is this one. Next one. The volume of the solid generated by rotating the region bounded by the lines y equal x, y equal 4 minus x, and x equal 0 about the x-axis. Well, the x-axis, I'm working with the x values. Okay. This is y equal x. Y equal 4 minus x. That will be 4. And that will be 4. So it will do something like this. And the x equals 0, which is the y-axis. This is the y-axis. So what is the region we are talking about? Is this one. This is the region. Okay. So I will do my line, my strip. This is my strip. Okay. About the x-axis, about this. So I have the upper minus the lower. So I have capital R of x will be what? The upper line, which is 4 minus x. Small r of x, the small line, which is x. And the area will be by r square minus small r square. That would be there. And from where to where? Yeah, this is 0. I need to find this point. How to find it? Just equate them. X equal 4 minus x. So it means 2x equal 4. So x equal 2. So this point is 2. This point 2. Okay. Oops. This is the x. Okay. So what is the volume? Integral from 0 to 2 of this by, what is this? 16 minus 8x plus x squared minus x squared dx. So that give me, this is cancelled. خلاص مع السلامة. That will be by 16x minus 4x squared from 0 to 2. That give me what? 32 minus, don't forget the by, minus 16, which is 16, which is this. Sorry, which is this. Okay, more problem to come. I have the function y equal x over 4, which is just this line, and x equal 2. This is x equal 2. And the x-axis, and the x-axis, sorry. And the x-axis. This is the x-axis. I want to rotate it about the y-axis. Okay. So my strip is this one, or my line is this one. So I need to think about the long one and the short one. So I have r of y will be what? 2 minus 0, which is 2. Small r of y, this small one, it will be, no, wait a minute, in terms of y. So I have x equal 4y, and it's everything in terms of y. X equal 4y. So the small r of y will be what? 4y. The area will be by r squared, capital R squared, 4 minus small r squared, 16y squared. So it is the volume, and that from where to where? That from as y 0, this is if x equal 2, y will be half. This is 2 and half. I need the y value. So integral from 0 to half of the 4 minus 16y squared dy. Yeah, fractions. Okay. By, this is 4y minus 16y cubed over 3 from 0 to half. That will be by, yeah, be careful with calculation now. 2 minus, yeah, this is will be what? 16 half cube 1 over 8 times 3, that 24. Yeah. At 4, it's, is it? That's 3 times 8. So 8 will make it 2, and this will make it 3. So I have by 4 over 3, or 4 by over 3. 2, 6 over 3 minus 2 over 3 is 4 over 3. Okay, more problems. Now I have what's my circuits. And the cross section is perpendicular to what? To the x-axis. Now we need to find the base. What will be the base? I graph the two functions. This is y equal x squared. Oh, what about this one? This one I need to rewrite it in a different way. So I have what? I can make it what? Y equal minus x squared minus 2x to see what is the vertex. Huh? Complete the square, multiply by minus 1. So I add 1. That will be minus x minus 1 squared plus 1. So the vertex is 1 and 1, but opens downward. So this is 1 and 1. This is my vertex. And it passes through 0, 0. So this is the function. Okay. Points of intersection. What are the points of intersection? Just equate them. You get what? 2x squared. Take everything to the other side. Minus 2x equals 0. Take 2x. X minus 1 equals 0. So it means x equals 0 and x equals. So that it will be 0. And that will be. No, and that will be 1. This is. Okay. Now let me do the strip. Or the line. Okay, this is my line. So I need the upper one. Oh, this will be my line. So the base will be what? Will be the upper one, 2x minus x squared minus x squared, which is 2x minus 2x squared. Don't forget, these are the diameter of the semicircle. So that will be 2r. So what will be r? R will be x minus x squared. And what is the area for this semicircle? Is pi over 2 the base or r squared. Pi over 2 r squared. Okay. If this is r, so the area will be what? Pi over 2 x minus x squared square. Oops. So the volume will be pi over 2 from where to where? From 0 to 1 of the base, of the area, which is x. What is this? X squared minus 2x cubed plus x to the power 4 dx. And that is pi over 2 times what? Here I have x cubed over 3 2x to the power 4 over 4, which is minus x to the power 4 over 2 plus x to the power 5 over 5 from 0 to 1. That gives me pi over 2 of what? 1 over 3 minus 1 over 2 plus 1 over 5. That's it. That will be pi over 2. What is the common denominator here? 30 times what? 10 over 2 is minus 15. Is it? Okay. Over 5 is 6. That gives me 16 minus 15. That gives me pi over 60. Good. Okay. The base of the solid, the region, this. Now things in terms of y square. Things in terms of y square. Okay. We want to find the, and the cross section perpendicular to what? To the y-axis. To the y-axis. Okay, so I need to, yeah, this is ready. Everything is ready. Okay, I have this, and I have this. X equal y square. This is x equal y square. X equal 2 minus y square. So this is 2, and this is the other one. Okay. Cross section perpendicular to the y-axis. So everything should be in terms of y. So this is my line. Okay. So this one, which is the base, will be what? Will be the upper one is 2 minus y square, the one to the right, I mean the bigger one, minus y square. And that is 2 minus 2y square. Since I have my circle, that will be 2r. So r 1 minus y square. Good. Now, what is the area for the small circle? The area will be pi over 2 r square. So it's pi over 2 times r square, which is 1 minus y square square. So it is the volume. Yeah, by the way, y values. The y values are from where to where? The y values are, note I have y equals 0. So I have the x-axis also. So I have this, so I will stop here. So the y values are from 0 to 1, where this is 1. Since he add the y equals 0, the x-axis. So I have this region. This is my region. Okay, so it will be pi over 2 integral from 0 to 1 of this r square. R square, which is 1 minus 2y square plus y to the power 4 dy. So this is my answer. Not this y equals 0. So I need to read everything. The following the series obtained the region closed by this about y equal minus 1 given by this integral. Let me grab the functions as usual. I have y equal x squared plus 2, and that is, this is the function, the first one. Second one, 10 minus x squared. So it will be, this is 10 somewhere. This is will be the other function. Okay, about what? Y equal minus 1, about this line. So I need this one, which is will be what? The bigger one minus the small one. So I have capital R of y is what? The bigger one, which is 10 minus x squared minus 1, which is 10 minus x squared minus 1. Yeah, not minus 1. So that will be 11 minus x squared. Small r of y will be what? X squared plus 2 minus 1. And that will be x squared plus 3. Great. What is the area? The area will be, and from where to where? Yeah, I need also to find the points of intersection. Let me equate them here. I don't have space. 10 minus x squared. That give me what? 2x squared equals 8. So x squared equals 4. So x equal plus or minus 2. Great. So the area will be what? By this square minus this square. Okay. So what is the volume? The volume will be by integral minus 2 to 2, this one, 11 minus x square minus x square plus 3 square dx. We don't have that. Oh, be careful. These are even functions. So that will be 2 by 0 to 2, the same function. Yeah, so sometimes you need to deal with such case. So this is my answer. Okay, more to go. Define the solid generated by revolving the region bounded by this. And notice this is always positive. So it's very difficult to graph it. But it's positive, it's above the x-axis, so I can't do it quickly. I have only, and they have what? X equal 1 and y equal 0, which is the x-axis. And the function is positive here. The function is positive somewhere. And you have to rotate it about the x-axis. So do my strip this way somehow. The function is doing something. Who cares? Okay. But it's always positive. So I have the r of x is the function. With the function minus 0. And the area will be by r square. And that will be 2x over x square plus 1 all square. And it is from where to where? From 0 to 1. From 0 to 1. So the volume is from 0 to 1 by this one. I need to integrate this. I let u equal x squared plus 1. Du will be 2x dx. Ready. So that will be by, what is that? I can't do it without doing u. That's 1 over u to the power minus 2, which means minus 1 over u from 0 to 1. That give me by of what? 1, give me minus half, 0 minus 1. That give me minus half plus 1, half, which is by 1. Okay. The volume solid obtained by returning the region closed by the curve y equal x square, or x equal this is given by what? Okay. Y equal x square about x equal minus 1. This is x equal minus 1 somewhere. Okay. So this is, I want it perpendicular to this. I will do it this way. So everything should be in terms of y. So I change everything in terms of y. X equal y. Here x equal square root of y. Because I need the positive side. Okay. So what I have here, capital R of y, the bigger one, will be what? Square root of y. Square root of y, this will be the bigger one, which is square root of y plus 1. Small r of y will be, will be this one. So it will be x minus 1, sorry, y plus 1. It will be y plus 1. Okay, and the area will be by this one square minus this one square. So the volume will be what? And from where to where? that. I want this from 0, and this point is 1. Y values, huh? That will be by from 0 to 1. First one square, that will be y plus 2 square root of y plus 1 minus y squared minus 2y minus 1 dy. That will be what? Y integral from 0 to 1, 2 square root of y minus y, that will be minus y. This is cancelled. Minus y squared dy. And that's my answer. Okay. The base of the solid bounded by this squares. Huh? I have squares. Okay. Let me graph the functions. 1 minus x squared over 4. How to graph it? It will be 1, something like this. Well, these values are what? At x equal 2, y is 0. So this is 2. This is what I need. Okay, at x minus 2, this is minus. I don't care about this. Why? Because look at the region. First quadrant, he said. And also he said x equals 0, y equals 0. So y-axis will be bound, the region will be bounded by all of this. I'm talking about this region. Okay. And about what? Yeah, x-axis. Okay. So this is my base. The base will be what? 1 minus x squared over 4. Minus 0. Okay. And from where to where? From 0 to 2. Because I need only this region. I need only this region. Okay. So the volume will be what? Will be the integral from 0 to 2. The area is the base square. The area of the square is the base square. This is the area. So the area will be 1 minus x squared over 4 all square. So the volume will be this. And that will be my answer. No by, huh? Don't forget, there is no by. Okay. Volume of the solid obtained by rotating the region bounded by the graphs of this about the x-axis. Okay. Graph it, see what is it. That will be y equals square root of x. I have y equals 0, which is the x-axis. X equal 1, x equal 5. So I'm talking about this region. And I want to rotate it about x. So I will do my line parallel to the, or perpendicular to the axis of rotation. So I have r of x. I have only r of x, square root of x. That's it. It's a disk method. So and from where to where? From 1 to 5. So the volume will be by, and what is the area? By r squared, which is by square root of x squared, which is by x. The volume is from 1 to 5. 1 to 5 by x dx. No, no need. That will be by x squared over 2 from 1 to 5. That will be by 25 over 2 minus 1 over 2, 24 over 2, which is 12 pi. That's it. More to go. The volume of the solid obtained by the region closed by the curves. Let me graph the curves. I have y equal x square. This is y equal x square. Y equals square root of x. That will be the other curve. And about the line, y equal -1. This will be the rotation. And so this is will be my line. So for sure, I have the quotient method where I have this. This is the outer radius. This is the inner radius. So R in terms of what? In terms of x. R of x will be what? The bigger one, which is square root of x plus 1. Small r of x. The smaller one, which is x squared plus 1. Minus 1, which is x squared plus 1. X squared plus 1. And the area will be what? Y, this one is square, minus this one is square. Great. From where to where? This is 0. For sure, this is 1. So volume will be y from 0 to 1 of this. Which is good. Here I have what? The base of a certain solid, the region bound closed by this perpendicular semicircle, x-axis. Okay. We did something before similar. Let me do it again. Let me do some. First, find the area. That will be square root of x. I have y equals 0, which is the x-axis. X equals 0, the y-axis, and I have x equal 1. So we're talking about this area. So what is the base? The base will be square root of x. And that equal to r. So r square root of x over 2. Great. Now, semicircle, what is the area? Y over 2 r square. That will be y over 2 x over 4. That will be y over 8x. And the volume, what is this? This is 1. 0 to 1. So the volume will be the integral of y over 8x dx from 0 to 1. And that will be what? Y over 8 x squared over 2 from 0 to 1. That will be y over 60. And that is the answer. Nice. Okay. Let me grab the regions. Sin x. I have sin x in this case. That will be sin x. And I want it only y equals 0, the y-axis, the x-axis, I mean, and the x equals 0 and x equal y over 2. This is y over 2. I want to rotate it about the line x equal minus. Okay. Be careful now. About the line x equal minus 1 to be perpendicular. This is my area, by the way. I have this. Okay. So I have the outer radius. Which is this. This one will be the outer radius. And this one will be the inner radius. No, wait a minute. I want the outer radius. The outer radius will be what? Yeah, this line to this, and the inner radius will be this curve to this. So I have the outer in terms of y. Be careful. I have y equals sine x. Then it means x will be sine inverse of y. So r of y will be which is pi over 2 minus minus 1, and that will be 1 plus pi over 2. And the inner radius will be the function in terms of y sine inverse of y minus minus 1, which is 1 plus sine inverse of y. And the area will be by this square minus this square. From where to where? The y values, this is 0, and this is, if x equal pi over 2, that will be 1. So the volume will be by integral from 0 to 1, the area, which is 1 plus pi over 2 square minus 1 plus sine inverse y square, the x. That's the answer. Okay. The volume of the solid generated by this is very clearly it's a positive one. So let me do it quickly. I have x equal 1, x equal 2, and the function is doing something positive. Square root of something is odd, and y equals 0. So about the x-axis. So this is the function. I don't care, but this is will be my string. So I have disk that will be r of x square root cosine by x over 4, and the area will be by cosine by x over 4. And the volume from where to where? From 1 to 2, very clear. So the volume will be by 1 to 2 of this, by cosine by x over 4 dx. I have y outside related to this. So this is by 4 over by sine by x over 4 from 1 to 2, which is 4 times what? Sine 2 over 4 sine pi over 2, that is 1. Sine pi over 4 square root 2 over 2. And that is what? 4 minus 2 square root of 2, which is. Yeah. Let me do more. See what I have. Big number. Who cares? I have the curves. This is parabola. Open to the right. X equals 0, the y-axis, and y equal 4. And they have y equal 4 somewhere. So we'll talk about this region. First, you need to find the region. About what? The y-axis. The rotation is about the y-axis. Okay. So to do my line perpendicular to the axis of revolution. So we'll do it like this. So I have r of y. I have a disk. R of y. Yeah, this is x equal y squared over 2. So r of y will be y squared over 2. The function in terms of the area will be by y to the power 4 over 4. Y squared over 2 all square. Let me do it. So I'm from where to where? This is 0. Y values. Talking about the y values. And this one is 4. This is what I'm looking for. So the volume will be by 0 to 4 of this, which is y to the power 4 over 4 dy. That will give me what? By y to the power 5 over 4 from 0 to 4. That'll give me by, don't forget, 4 times 5. So that will be y over 5, 4 to the power 5 over 4, that will be 4 to the power 4. And that is 256 by over 5. That's it, my answer. Yeah. Let me do this one. We have y equal ln x. Let me graph it first. Y equal ln x. That is ln x. We have x equal 1. Here x equal 1. And x equal e. And y equal 0. اللي هو x axis. About the line y equal -2. This is y equal -2. Okay. So about the line y. So perpendicular. We'll do this. Okay. So I have r of x will be what? Ln x minus -2. And that will be ln x or 2 plus ln x. Let me write it. 2 plus ln x. To avoid any confusion. Small r of x will be what? 0 minus -2. 0 minus -2. And that is 2. And the area will be by this one. 2. No need for anything else. 2 plus ln x all square minus 2 square. That will be from where to where? From 1 to e. 1 to e. So the volume by 1 to e, open this, 4 plus 2 ln x plus 4 ln x. Not 2, plus 4 ln x plus ln x all square minus 4 dx. Cancelled, and I have the answer. Ln x all square plus 4 ln x. I think we need a parenthesis here. To avoid any confusion. And that will be my answer. Let me finish my disk question. I have equatorial triangle. And I have x equal y cubed. This is the graph for x equal y cubed. And y equal 1. This is y equal 1. The region bounded by this, which is this region. Talking about this region. And what is my base? The base, I want it what? Perpendicular to the y-axis. So I'm talking about this. This is will be my base. So the base will be what? Y cubed. That will be by the base. And the equatorial triangle, what is the area? Square root 3/4. The base is square. Okay. This is y cubed. And from where to where? This is 0. And the y values, this is 1. So from 0 to 1. So the volume will be from 0 to 1. Square root 3/4. The base square, which is y to the power 6 dy. That will be square root 3/4 times y to the power 7/7 from 0 to 1. That gives me square root 3/28, which is this one. Yeah, I think we did good number of questions. Let me stop the recording. Yeah. Thank you.